to another video. Today we'll be learning about this topic, which is Tower of Hanoi. So let's try discussing what it is and how this problem came into existence and what is the solution around this using recursion. Okay, so the first thing, Tower of Hanoi, right? So the problem states that there are three towers. Okay, let's suppose that this is tower A, this is tower B, and this is tower C. So A is the source tower and B is a auxiliary tower, or you can say it as a proxy tower. Like this, we are using this to transfer the item from E to C, and C is the destination tower. Okay. So the problem states, let's start from starting. So let's suppose that there is only one disk. Okay. In this first tower, if there is only one disk, how do we transfer it from E to C? So it's pretty simple. We can just transfer it to C using B. So we are not using B actually, but we are just saying that we are using B because we want to use one tower at least to transfer to C. So we say we transfer A to C using B. Now let's suppose there are two disks. Okay, so there are two disks, and I forgot to say the rules. The rules are like at a time you can transfer only one disk, and second rule is no larger disk should be upon smaller disk. Okay, so these two rules we have to follow by transferring the disk from A to C. So one disk transfer is pretty easy. Now transferring two disk, what we can do, let's suppose let's name it 1 and 2. So what we will do, we will first transfer this to B, right? Two disk will be on B, then this one disk will be on C. Okay, and then we can transfer this disk to C. Okay, this using this way we can transfer this disk pretty easily. So what we have done, we have transferred two disk from A to C using B. Okay, this was pretty easy. So the steps we followed here is, first we have transfer one disk from E to B, then we have transfer from E to C, then we have transfer one that B to C. Okay, so steps are, first transfer one disk from A to B, then transfer another disk from A to C, then the last disk that is pending we just transfer it to C. Okay, so these are the steps we followed. Now what about if there are three disks? Let's suppose, let me redraw this. Okay, E, B, C. Let's suppose there are three disks, one, two, three. Okay, now for these two disks we can follow these steps again. Okay, the steps we already saw, we can follow those steps, and for the third disk we know how we transfer one disk, right, using this method. Okay, so using recursion we can easily transfer this disk from E to C. So the code, what would be our code? So the function would, the also one more scenario that I want to say, that this problem came into existence, like I'm not sure, like in India there was one temple where where this structure was made. A, B and C, these three towers were there, and whichever monk were able to transfer, I think there were 7 to 10 disks, whichever monk was able to transfer this disk from A to C using B with the following 1 and 2 rules, which is which I have already mentioned, and those monk would be claimed as graduate. Okay, so this is how it came into existence, and after the introduction of recursion, this problem was very easy to solve. So what we will do in recursion is like there will be of course a base condition. So if n is greater than 0, then what we will do, of course there will be a function which will accept n, E, B and C. Okay, so A is the source tower, C is the destination tower, and the B is our using tower. Okay, so if n is greater than 0, what we will do, we will call this, let's suppose this function name is TOH. We will call TOH for n minus 1. N minus 1 means we are just making sure that the number of disks are getting reduced. Okay, so n minus 1, we will transfer from E to B using C. Okay, so this will be the head recursion. Okay, and after this we will just print that we have transferred from print, just to know that we have transferred. So E to C is transferred. Okay, and we will just say that we are moving from A to C. Okay, and after that we will have another tail recursion call, which will be n minus 1 again, and this will be from C to B, right? So oh, not from C to B, wait, it will be B to E. Okay, C will be the auxiliary tower, which will be using tower. Using this recursion, we can easily see that any number of disks we pass to this function can be transferred from E to C. So just remember that first transfer from A to B, then from B to C. This is C, not E, my bad. Okay, so it will be B to C. So first E to B, then B to C, and whatever tower that is remaining, that will be our auxiliary or using tower. So that is the easiest way to remember this solution, and you can try writing this function and let me know. Thank you.